This is the story of an epic adventure. A story of cosmic curiosity, courage and perseverance. The story of how Europe went south to explore the stars. Welcome to ESO, the European Southern Observatory. 50 years old, but more vital than ever. ESO is Europe's portal to the stars. Here, astronomers from 15 countries join forces to unravel the secrets of the universe. How? By building the largest telescopes on Earth, designing sensitive cameras and instruments, scrutinizing the heavens. Their work has looked at objects near and far, from comets traversing the solar system to distant galaxies at the very edge of space and time, giving us fresh insights and an unprecedented view of the universe. A universe of deep mysteries and hidden secrets, and staggering beauty.
From remote mountaintops in Chile, European astronomers are reaching for the stars. But why Chile? What made the astronomers go south?
The European Southern Observatory has its headquarters in Garching, Germany. But from Europe, only part of the sky can be seen. To fill in the gaps, you have to travel south. For many centuries, maps of the southern sky showed extensive blank areas, the terra incognita of the heavens. 1595. For the first time, Dutch traders set sail to the East Indies. At night, navigators Peter Kaiser and Friedrich de Houtman measured the positions of more than 130 stars in the southern sky. Soon, celestial globes and maps showed 12 new constellations, none of which had ever been seen before by any European. The British were the first to construct a permanent astronomical outpost in the Southern Hemisphere. The Royal Observatory at the Cape of Good Hope was founded in 1820. Not much later, John Herschel built his own private observatory close to South Africa's famous Table Mountain. What a view! Dark skies, bright clusters, and star clouds high overhead. Little wonder that Harvard, Yale, and Leiden observatories followed suit with their own southern stations. But the exploration of the southern sky still took lots of courage, passion, and perseverance.
Until 50 years ago, almost all major telescopes were located north of the equator. So why is the southern sky so important? Well, first of all, because it was largely uncharted territory. You just can't see the whole sky from Europe. A prominent example is the center of the Milky Way, our home galaxy. It can hardly be seen from the northern hemisphere, but from the south it passes high overhead. And then there are the Magellanic Clouds, two small companion galaxies to the Milky Way. Invisible from the north, but very conspicuous if you're south of the equator. And then finally, European astronomers were hindered by light pollution and poor weather. Going south would solve most of their problems.
A scenic boat trip in the Netherlands, June 1953. It was here, on the IJsselmeer, that the German-American astronomer Walter Baade and the Dutch astronomer Jan Oort told colleagues about their plan for a European observatory in the southern hemisphere.
Individually, no one European country could compete with the United States. But together, they might. 7 months later, 12 astronomers from 6 countries gathered here, in the stately Senate room of Leiden University. They signed a statement expressing the desire to establish a European observatory in South Africa. This paved the way for the birth of ESO. But hang on, South Africa?
Well, it made sense, of course. South Africa already had the Cape Observatory and, after 1909, the Transvaal Observatory in Johannesburg. Leiden Observatory had its own southern station in Hartbeespoort. In 1955, astronomers set up test equipment to find the best possible spot for a big telescope. Zeekoegat in the Great Karoo or Tafelkopje near Bloemfontein. But the weather was not all that favourable. Around 1960, the focus shifted to the rugged landscape of northern Chile. American astronomers were also planning their own Southern Hemisphere observatory here. Harsh horseback expeditions revealed much better conditions than in South Africa.
In 1963, the die was cast. Chile it would be. 6 months later, Cerro La Silla was picked as the future site of the European Southern Observatory. ESO was no longer a distant dream.
In the end, 5 European countries signed the ESO Convention on the 5th of October 1962, the official birthday of the European Southern Observatory. Belgium, Germany, France, the Netherlands and Sweden were firmly committed to jointly reach for the southern stars. La Silla and its surroundings were bought from the Chilean government. A road was built in the middle of nowhere. ESO's first telescope took shape at a steel company in Rotterdam. And in December 1966, the European Southern Observatory opened its first eye on the sky. Europe had embarked on a grand voyage of cosmic discovery. $167,000 years ago, a star exploded in a small galaxy orbiting the Milky Way. At the time of the distant explosion, Homo sapiens just started to roam the African savanna. But no one could have noticed the cosmic fireworks, as the blast of light had only just embarked on its long journey towards Earth. By the time light from the supernova had completed 98% of its journey, Greek philosophers had just started to think about the nature of the cosmos. Just before the light reached Earth, Galileo Galilei trained his first primitive telescopes on the heavens. And on the 24th of February 1987, when photons from the explosion finally rained down on our planet, astronomers were ready to observe the supernova in great detail.
Supernova 1987A flared up in the southern sky, unobservable from Europe or the United States. But by this time, ESA had built its first big telescopes in Chile, providing astronomers with a front row seat to this cosmic spectacle.
The telescope is, of course, the central tool that allows us to unravel the secrets of the universe. Telescopes collect far more light than the unaided human eye, so they reveal fainter stars and let us peer deeper into space. Like magnifying glasses, they also show finer detail. And when equipped with sensitive cameras and spectrographs, they provide us with a wealth of information about planets, stars and galaxies.
ESO's first telescopes on La Silla were a mixed bunch. They ranged from small national instruments to large astrographs and wide-field cameras. The 2.2-meter telescope, now almost 30 years old, is still producing some of the most dramatic views of the cosmos. La Silla lies the biggest achievement of ESO's early years, the 3.6-meter telescope. Aged 35, it now leads a second life as a planet hunter. Also, Swedish astronomers built a shiny dish 15 meters across to study microwaves from cool cosmic clouds. Together, these telescopes have helped to unveil the universe in which we live.
Earth is just one of 8 planets in the solar system. From tiny Mercury to giant Jupiter, these rocky spheres and gaseous balls are the leftovers from the formation of the Sun. The Sun, in turn, is a middle-of-the-road star in the Milky Way galaxy. One pinprick of light amidst hundreds of billions of similar stars, as well as bloated red giants, imploded white dwarfs, and rapidly spinning neutron stars. The spiral arms of the Milky Way are sprinkled with glowing nebulae, spawning bright clusters of newborn stars, while old globular clusters slowly swarm about the galaxy. And the Milky Way is just one of countless galaxies in a vast universe, which has been expanding ever since the Big Bang, almost 14 billion years ago.
Over the past 50 years, ESO has helped to uncover our place in the universe. And by looking up, we have also discovered our own origins. We are part of the big cosmic story. Without stars, we wouldn't be here.
The universe started out with hydrogen and helium, the 2 lightest elements. But stars are nuclear ovens, turning light elements into heavier ones. And supernovae, like 1987A, seed the universe with the products of this stellar alchemy. When the solar system formed some 4.6 billion years ago, it contained trace amounts of these heavier elements, metals and silicates, but also carbon and oxygen.
The carbon in our muscles, the iron in our blood, and the calcium in our bones were all forged in an earlier generation of stars. You and I were literally made in heaven.
But answers always lead to new questions. The more we learn, the deeper the mysteries become. What is the origin and ultimate fate of galaxies? Are there other solar systems out there? And could there be life on alien worlds? And what lurks in the dark heart of our Milky Way galaxy?
Astronomers were clearly in need of more powerful telescopes, and ESO provided them with revolutionary new tools. Bigger is better, at least when it comes to telescope mirrors. But larger mirrors have to be thick so that they don't deform under their own weight. And really large mirrors deform anyway, no matter how thick and heavy they are. The solution? Thin, lightweight mirrors and a magic trick called active optics. ESO pioneered this technology in the late 1980s with the New Technology Telescope. And this is the state of the art. The mirrors of the Very Large Telescope, the VLT, are 8.2 meters across, but only 20 centimeters thick. And here's the magic. A computer-controlled support system ensures that the mirror keeps its desired shape at all times, to nanometer precision. And active optics, the VLT wouldn't be possible. But there's more. Stars appear blurry, even when observed with the best and largest telescopes. The reason? The Earth's atmosphere distorts the images.
Enter the second magic trick, adaptive optics. On Paranal, laser beams shoot out into the night sky to create artificial stars. Sensors use these stars to measure the atmospheric distortions, and hundreds of times per second, the image is corrected by computer-controlled deformable mirrors.
And the end effect? As if the turbulent atmosphere were completely removed. Just look at the difference.
The Milky Way is a giant spiral galaxy, and at its core, 27,000 light-years away, lies a mystery that ESO's Very Large Telescope helped to unravel. Massive dust clouds block our view of the Milky Way's core, but sensitive infrared cameras can peer through the dust and uncover what lies behind. Assisted by adaptive optics, they reveal dozens of red giant stars. And over the years, these stars are seen to move. They orbit an invisible object at the very centre of the Milky Way. Judging from the stellar motions, the invisible object must be extremely massive. A monstrous black hole weighing in at 4.3 million times the mass of our Sun. Astronomers have even observed energetic flares from gas clouds falling into the black hole, all exposed by the sheer power of adaptive optics.
So thin mirrors and active optics make it possible to build giant telescopes. And the adaptive optics take care of the atmospheric turbulence, providing us with extremely sharp images. But we're not done yet with our magic tricks. There's a third one, and it's called interferometry.
The VLT consists of 4 telescopes. Together, they can act as a virtual telescope measuring 130 meters across. Light collected by the individual telescopes is channeled through tunnels and brought together in an underground laboratory. Here, the light waves are combined using laser metrology and intricate delay lines. The net result is the light-gathering power of 4 8.2-meter mirrors and the eagle-eyed vision of an imaginary telescope as large as 50 tennis courts. 4 auxiliary telescopes give the network more flexibility. They may appear tiny next to the 4 giants, yet they sport mirrors 1.8 meters across. That's bigger than the largest telescope in the world just 100 years ago.
Optical interferometry is something of a miracle. Starlight magic wielded in the desert. And the results are impressive.
The Very Large Telescope Interferometer reveals 50 times more detail than the Hubble telescope. For instance, it gave us a close-up of a vampire double star. One star is stealing material from its companion. Irregular puffs of stardust have been detected around Betelgeuse, a stellar giant about to go supernova. And in dusty disks surrounding newborn stars, astronomers have found the raw material of future Earth-like worlds. The Very Large Telescope is mankind's sharpest eye on the sky. But astronomers have other means to expand their horizons and broaden their views. At the European Southern Observatory, they have learned to see the universe in a completely different kind of light.